Welcome to One Chemistry. In this video, we are going to see Birch reduction reaction. It is an important naming reaction. It involves regioselectivity and has more potential for tricky question. Stay tuned. For quick reference, I given a library of facts. If reagent contain electron donating group, double bond form near it, electron withdrawing group form away from it, cyclic system, phenolic system, heterocyclic system. This will help you to solve the problem. Better you memorize it. It will help you to recall quickly. First, let us see what is pitch reduction. Pitch reduction is the unique reaction. It involves the reagent metal in ammonia. You are using alcohol for a hydrogen. The metal provides the electron. Electron form complex with ammonia. You can say it's a solvated electron. Electron at center. Ammonia stabilize it. It is a kind of electron ammonia complex. Just a given a imaginary structure. The metal can be lithium, sodium and potassium. Lithium has more reactivity. Mostly lithium will be used. As a standard, I given a benzene. If you use lithium ammonia with alcohol, you have reduction at 1,4 position. Double bond shifted. You have 2 hydrogen as a addition. You added 2 hydrogen. So basically it's a regioselective reduction. Reduction happen at 2 carbons. Interestingly in different carbon. That's why the reaction is getting interesting. We will see why it is happening. What is the reason behind that? Here I given a mechanism. It is a set mechanism, meaning single electron transfer. Mostly metal provides the electron. The electron can induce radical anion in the benzene ring. Anion and radical separated far away because of same charges. It will repel each other. That's why reduction happen at 1,4 position or far away position. Radical at one position, anion at another position. Here anion get quenched by H plus. You have reduction there. Similarly, radical can convert into anion by providing another electron. Since metal contain Avogadro number or stoichiometric electron, it can reduce radical to anion. The anion again quenched by H plus. So reduction happen at two different position, 1,4 position. So H plus addition practically to the reduced product. It is very unusual because reduction happen at two different places very selectively. That is why it is called regioselective reduction. You need not to know the mechanism. If you know the shortcut, you can straight away you can write the product. Mechanism can be interesting if it is attached with electron withdrawing group or electron donating group. First, let us see electron withdrawing group. If electron withdrawing group present, it can stabilize the anion. So what really happened? Once the electron added, radical anion form, but anion form near the electron withdrawing group. Electron withdrawing group can be normal ones, that is minus IF8 groups, cyanide, nitro, carbonyl, acid, aramide. So anion form near that because of stability, then quenched by hydrogen, then radical again converted into anion, again it is quenched by hydrogen, the reduction happened. So if it is electron withdrawing group present, you have anion will form near that, ended up reduction near to electron withdrawing group. So the carbon near electron withdrawing group get reduced. In that fourth position also reduced. So electron withdrawing group promote the anion stability, which promote regioselectivity. Now we are seeing the opposite case, electron donating group. Suppose you have electron donating group in the benzene, what will happen to the mechanism? So electron added by lithium metal form radical anion. Since it is electron donating group, it will destabilize the anion. What really happened? It will form away from the electron withdrawing group. So radical anion form at 1,4 position but away from electron donating group. Then anion get quenched by H plus. You have reduction there. Then you have radical. Again it converted into anion by electron addition. It form anion. Then anion quenched by H plus. You have hydrogen. So if you look at closely, here also 1,4 reduction happened, but far away from electron donating group. That's why it is regioselective, controlled by electron donating group tendency. Now we are seeing the another case, that is heterocycle case. In most of the real life situation, the rings containing the heteroatom. Here I shown the quinoline A and B ring. B ring contain nitrogen. Here you may wonder where the reduction will happen. The reduction happen at the nitrogen ring because electron density of B is lesser than A, because nitrogen is electron withdrawing due to electronegative nature. It makes the ring electron deficient, so it catch the electron. Reduction happen at the nitrogen ring at 1,4 position. So it is a different kind of selectivity due to the heteroatom. So quinoline reduction happen at nitrogen ring. Then another interesting case, naphthalene, where the reduction will happen. Here if you look at it, all the carbon looks similar, but anion only form from away the position. But anion will form away because of same charges. So different rings, same 1,4 reduction happen. So the reduction happen at 1,4 and 5,8 position. If you look at it, you can clearly see two-time Birch reduction happen. The mechanism is like benzene reduction case. Problems are best way to learn, best way to understand the concept. That's why I given some problems to make the concept more deeper. Let us see the first problem. Here you have benzene attached with OCH3 group. It is ether, anisole. Lithium and liquid ammonia you are using with H plus. You should find what will be the final product. Here OCH3 group is there. It is electron donating group, mesomeric in nature. So what really happened? Radical anion don't form near the, so anion form away from OCH3 group. Reduction happen at 3,6 position. The interesting case is H plus. Since H plus readily available in the system, it can convert ether into alcohol. If you look at the compound, it is enol. It will convert into hetoenol tautomerism. So enol become ketone. Further acidic condition convert into conjugation. The driving force for the isomerization is conjugation. That's why final product is alpha beta unsaturated ketone. Then the second example, here you have benzene ring attached with ester and methyl group, lithium and liquid ammonia you are using. We should find what will be the final product. The question is really about, you have both electron donating and withdrawing group is there. What could be the possible product? Here you have two conditions, so you have to find the middle path to have the final product. Since you have carbonate, it is sp2 carbon, electron withdrawing in nature because of more s character. So reduction happen near that. So 1,4 reduction should happen. If you look at the methyl, same mechanism can apply. Reduction happen away from methyl group. So reduction happen in same 1,4 way. So if you look at two different cases, you take COOH as main group, same 1,4 reduction. CH3 main group means same 1,4 reduction. The question creates the confusion, but if you know the fundamental, you can find the answer very clearly. Then the next example, here you have fused system with cyanide, you have lithium and liquid ammonia. You should find what will be the final product. Here fused ring system is there, two rings are there where the reduction will happen. Since the reaction involve electron transfer, the ring with less electron density promote the electron absorption. So A ring got reduced, not the B ring. It is another selectivity. First selectivity is 1,4 reduction. Second selectivity is a ring reduction. So A ring is electron deficient, electron added. Then cyanide is electron withdrawing group. What really happened? The reduction happened at cyanide carbon. You end up in 1,4 position. The concept you have to learn here is in fused ring system, two selectivity will come. One is from electron, another is from ring electron density. Then the next example, here you have benzoic acid, benzene with COOH, lithium and liquid ammonia you are using. You should find what will be the final product. Here, if you rewrite the acid very clear way, it is COOH, carbonyl is there, it is sp2 carbon, electron withdrawing in nature. So, reduction happen near the carbon. So, 1,4 reduction happen, electron donation and reduction happen at the same time. You have 1,4 reduction. If electron withdrawing group present means the reduction happen at the alpha carbon which near to the electron withdrawing group. Then the next example, here you have benzene, side chain you have alkene, lithium and liquid ammonia you are using. You should find what will be the final product. Here you may got confused which group is alkene, whether it is electron donating or electron withdrawing. If you look at it, side chain is electron richer, so you should consider it like electron donating group. So reduction happen at 1,4 position, which is away from the electron donating group. So side chain form with conjugation, 1,4 reduction happen, that is 3,6 carbon got reduced. Then again lithium and ammonia has the potential to reduce further because it can reduce conjugate carbon. You end up with final exocyclic double bond. So until the conjugation is there, lithium and liquid ammonia react, same reagent react twice, you have the final product. The concept you have to learn here is double bond behave like electron donating group. The reduction happen away from that carbon.